Hi everyone. Now I am going to give lecture on the topic of basic principle of measurements. So let us see the basic components in a measurement system. So these are all the basic components that should be present in a measurement system. So you can see this is measured medium. So this is what we are going to measure. For example, we want to measure a temperature or voltage or current. So these are all the measured medium. Then the measured quantity will be given to this instrument. So this is here the interface should be present. So the first element is primary sensing element. So the purpose of primary sensing element is, this is the first element. It will contact with the measured medium. And the next one is variable conversion element. So here variable conversion element means it may be measured in analog, but the instrument will be displayed only the digital output. So that analog should be converted into digital. So here the DAC, ADC or the variable conversion element, which is used to convert variable from one form, that is analog to digital form or digital to analog form. So for that purpose we are using variable conversion element. And the next one is variable manipulation element. So the purpose of variable manipulation element is, so the voltage or current level may be low. Okay, current amplitude may be low. So you have to increase the level. You have to manipulate it. You have to increase or decrease the level. So that can be done with the here. For example of this variable manipulation element is amplifier. So the purpose of amplifier is increase the magnitude level. So this is the purpose of variable manipulation element. And the next one is data transmission element. So the purpose of data transmission element is, it will transmit the data from one place to another place. For example, in industries, the quantity will be measured in the manufacturing plants, but the data will be the data will be sent to the control unit. So with the help of data transmission element, we can transmit the data from manufacturing plant to the control room. And the next one is data presentation element. Before that, we can store the data in data storage element. And the last one is data presentation element. So here it will present the value of the measured quantity to the observer. So this is the presented data to the observer. So here it is the last data presentation element is the last element. So it is used to interface with the observer. So it is also important to mention that a power supply is an important element for the entire system. And the next one is instrumentation characteristics. It shows the performance of the instruments to be used. It can be divided into two categories, static and dynamic characteristics. Static characteristics refer to the comparison between steady output and ideal output when the output is constant. Dynamic characteristics refer to the comparison between the instrument output and ideal output when the input changes. And the first one is static characteristics. The first one of the static characteristics is accuracy. Accuracy is the ability of an instrument to show the exact reading. So what accuracy means? So you have to get the accurate value what you need to measure. For example, if you want to measure a 15 volt voltage value, you should get, with the help of that instrument, you should get exact 15 voltage, not 14.9 or 15.1. You should get the exact 15 voltage. It always related to the extent of the wrong reading or non-accuracy, normally shown in percentage of error, which of the full scale reading percentage. And the next one is precision. So if you are using an instrument to measure a quantity for several times, so it should be the same, the value should be the same. So an equipment which is precise, not necessarily accurate, we can tell. Defined as the capability of the instrument to show the same reading when used each time. So whenever you are using to measure a 15 voltage value, it should show the 15 voltage. Okay, so that is precision. And the next one is, what is the difference between accuracy versus precision? So precision means it should give the same value whenever measuring each time. So it may give the same wrong value whenever it measuring. For example, instead of giving 15 voltage, it may give 11 voltage whenever it is measuring. But that is not accurate. Precise means all the values should be near, closer, or while measuring each time. Accurate value should be, it should be closest to the true value what you want to measure. And this is the from this graph you can see. So this is measurement value and this is number of measurements. So high accuracy means that the mean is close to the true value, while high precision means that the standard deviation sigma is small. And the next characteristics is tolerance, closely related to accuracy of an equipment, where the accuracy of the equipment is sometimes referred to in the form of tolerance limit, defined as the maximum error expected in an instrument. Explains the maximum deviation of an output component at a certain value. And the next one is range of span, defined as the range of reading between minimum value and maximum value for the measurement of an instrument. Has a positive value. Example, the range of span of an instrument which has a reading range of minus 100 degree to 100 degree Celsius. So it can measure from minus 100 degree Celsius to 100 degree Celsius. So totally it can measure 200 degree Celsius. Okay. So the range of span is 200 degree Celsius. The next one is bias, constant errors which occurs during the measurement of an instrument. This error is usually rectified through calibration. Next one is linearity, maximum deviation from linear relation between input and output. The output of an instrument has to be linearly proportional to the measured quantity, normally shown in the form of full scale percentage. The graph shows the output reading of an instrument when a few input readings are entered. So linearity is maximum deviation from the reading of and the straight line. So here you can see the measured quantity and the output reading. It should be linear. And the next one is sensitivity, defined as the ratio of change in output towards the change in input at a steady state condition. So here the sensitivity can be written as change in input to change in output to change in input. The next one is dead space or dead band. It is defined as range of the input reading when there is no change in the output. Whenever you are changing input, the output should be changed. So up to this space it doesn't, while if even though you are changing input, there is no variation in the output. So you can tell this as dead space or dead band. And the next one is resolution, the smallest change in input reading that can be traced accurately. That is, if you are changing a voltage value in the range of 0.001, the output also in similar manner, while the reading also should be changed in 0.001 value. So it will be given in the form of percentage of full scale, available in digital instrumentation. And the next one is threshold. When the reading of an instrument is increased from 0, the input reading will reach a certain value before change occurs in the output. The minimum limit of the input reading is threshold. For example, we can tell the threshold voltage of the silicon semiconductor as 0.7. So after attaining 0.7 voltage, the silicon devices will start to conduct. Thank you.